You know, we generally don't stop in the tent too much because we don't have a lot of time. But when we see something that is going to make our experience on the water better and that also helps the environment, we're always going to stop. I've just met Pierre Calwet, who spent the last couple of years sailing around the world on a 50-foot cat. And he's come here for the first time with something that it may very well change the way long-distance cruising happens. Now, we've all seen the systems of regenerating energy, and they've all left something to be desired. Explain what you've got here, Pierre.
Well, it's tried to get the best out of the bus market, the car market, the marine market. What are the best technology available today? Trying to integrate everything through communications system and program through a fairly high-performance communication controller. All of the interfaces and trying to make it the system as easy and as efficient as possible. So you found the best stuff
to run your boat with an electric motor, and this you told me is a 75 horsepower equivalent motor. This thing here is 90 pounds. So imagine the savings that you're going to get out of everything when you start to lighten the boat up like this. We've also seen a lot of the big maxis start to go to hydraulic or electric drives too for the same weight reasons. So the components are an electric motor. What else? We
have the controller that basically takes the voltage, DC voltage, into pulses that the motor can understand both ways. Because of course, even at low RPM, you want to be able to regenerate. So the controller has to be able to upscale voltage the same way. So that's extremely important. And then we've got the shore battery charger that is all CAN bus control, water cooled, very, very important, because this way you can get 100% duty 24 hours a day. It doesn't generate any heat in the cabin. It's extremely efficient. It's all controlled from CAN bus.
Now that runs off a generator or the shore power, correct?
Yeah, well, this one is more or less shore power because the generator ties right into the battery pack.
Right.
And here we have the opposite, which is a DC-DC. That will take your high voltage battery into your low voltage battery bank. This guy will give you 160 amp of power and 12 volts continuously, 24 hours a day if you want to. And it's water cooled for low regeneration, extremely efficient. So that's a new technology.
Yeah, it sure is.
This weighs 6 pounds, this weighs 8 pounds.
Now who's developing this technology? Where is it coming out of this thing?
The electric car industry and the electric bus industry. You know, there's no point in trying to reinvent the wheel here, because this is technology that has moved a lot in the last few years. So basically just adapting it back to the boat. And in this case, the only thing that is required is intelligent interface to make it easy to use and efficient.
And that's what you developed?
Yes.
So you do full kits for boats from what size and up?
Well, right now, because of the cost of the technology, we restricted ourselves to 50 foot and up. We're working with manufacturers into designing the whole boat around a high voltage battery bank, because that's a storage for everything. And then from that point on forward, as the price of technology drops, we will go down into both sizes.
When these motors need maintenance, who's qualified to fix them? Like, I'm a diesel mechanic, but I wouldn't know. I would not have any idea.
Fine, 100,000 hours. After 100,000 hours, you remove the bearings, you put new one on. That's it.
So it won't break. No.
And it's water cooled, so it's already moisture proof. IP65.
Lot nicer than crawling into the bilge and changing the oil.
You know, of course, you always get into the argument of salt water, air, and everything else. I've just came back around the world, and we never had one drop of water in our house. So it's possible to have a dry boat. But having said this, the bus industry is not the most friendly environment anyway. So if these things are installed in bus, and you've been running for years in bus, under the rain, dirt of the street, and everything else, in San Francisco and all these other places, why isn't it going to work on the boat? It's a big question. You know, it should work.
Now, what about galvanic corrosion and electrolysis?
Well, this is one issue which is very, very dear to the heart of all the sailors. So first thing that is very important is you have to insulate yourself from shore power as soon as you can. So these type of chargers are fully insulated both ways. So it doesn't matter where you're plugged in, whether it's in Europe, whether it's in America, 120, 240, 230, whatever the areas are, you have to be fully insulated from it. And the whole battery high voltage system is fully insulated also, floating type system. You know, we're working with ABYC, defining the new high voltage DC standards right now, which are, you know, very defined. We're using shielded cable everywhere in the boat. As soon as you see, we monitor the difference between the core insulation of this system. we can detect if just one of those cables is bent, we can detect it in our systems. That's how accurate it is, and how safe it is. So the whole technology has evolved to a point where it's extremely friendly, extremely powerful, and efficient.
When you outfit a boat with the system, is there any reason for you to ever have fuel on the boat at all? With like a hybrid car, they still use fuel.
Yeah.
So would you still?
We have some users that are strictly electric. So they plug into shore power, leave the dock, sail up, get out of the way a half an hour, put the sails up, start sailing. If the batteries are low, they recharge with the prop, and then they come back home after a day or two. That's fun. We also the other extreme of people which are sailing around the world that will want some form of independence if they are at the hook for a few days. So then, yes, we will have a generator, but it has to have a storage medium, hypercapacitors or batteries in the middle that will give you propulsion, that will accept the regeneration, give you power for your households, and then also will accept if you have a generator, to be able to operate the generator in optimum mode so that it runs as little as possible.
What's the website over here? Is that it?
Yes.
All right, so guys, Regen Nautic, they have some really cool ideas. The way this controller works is really neat, as Pierre explained us before. The one thing I thought was pretty fascinating was how this smart system plays with the prop to give you either more power, less power, to change your to take away the drag. Explain that real quickly.
Yes, well, it's actually very, very simple. Most sailors are used to having either folding props or feathering props to try to get rid of the drag while we're sailing. With electric motors, since we don't have a diesel or gas engines turning it, we're not caught with the efficiency area of the curve. So we find that just installing a fixed blade prop with a high surface provides us better propulsion, a better regeneration, and once we're done with it, what we do is we send a very, very low pulse to the motor, actually 0.4 amps, the equivalent of a light bulb in power. And this will actually just help the motor turn a little bit faster than the water flow and completely cancels the drag altogether. And until the system detects it, until the battery voltage is back down to a point where it needs to be recharged again, then it just flips back into regeneration again for half an hour to bring the battery back up, and then it goes back into no drag again. So this is one of the big functions, of course, of the system that is allowed with the efficiency of a high-capacity upscaler like this. It will take even very low RPM and give you a charging voltage.
Say I have a 50-foot boat that weighs 30,000 pounds, and I'm building it now, and I want to have no main motor. I want to have as small a generator as I can, and I want to have this entire system. What's the weight?
Weight will be lighter.
It'll be lighter. How much?
It depends on how much battery storage you want. And
right.
There again, once we're in the battery, we say, well, do you just need 6 or 8 kilowatt, about 400 amps, 600 amps that people usually have in their boats for day sailors. It would allow you to power out of the dock, raise the sails,
right,
and then come back. But if you want more independence, the worst case scenario for me is somebody that tells me I want to be able to run my AC all night without having to run the generator.
On the hook for a week.
At least for the night. So in that case, they need about 40 kilowatts of storage.
Right.
So these are the extreme that I see.
Right.
So, but once you decide how many kilowatts of storage you want to keep in your boat, then the next question is the technology of it, which will affect the weight of it.
Could you switch the batteries out if you decided, like, down the road that you're going to do a different kind of sailing, like go from day sailing to cruising? Would you be able to switch components out to match what you want to do?
Oh, absolutely, because that's the beauty of the system. You just program it. You say, well, this is the type of battery bank I have now, so you just put the parameters in. As long as you're at 250 to 400 volts, it's fine. But the advantage of it, as you mentioned, is the car industry now. It's starting to come in with those batteries. The bus industry has it. And the price is dropping. So one could very well say, like I've had a couple of people that say, well, how about if I put AGM batteries now, and then 6 months, a year, 2 years from now, when they start to get old, I go in and get one of those new car batteries. You can put a Tesla battery, a nice little 44 kilowatt battery from Tesla, right into your boat, plug into it, and you're up and running. Absolutely. The same thing with a smaller Prius battery.
Yeah. One more question, and we got a break. But compared to conventional powering, price.
Yes.
What is it?
Right now, it's at least double.
Okay.
It's still expensive. But we go through the same mechanism with the battery storage.
It's going to get better and better.
Lead acid versus lithium titanium battery, which are probably the best on the market now. Yes, they are very, very much more expensive. We're looking at about $500 per kilowatt for a lead acid.
I got a break. I got to cut it now.